Hello, today we are going to be working on graphing quadratic equations. The first set of graphing equations will be in the form of standard form, y equals ax squared plus bx plus c. To find the vertex, we're going to use x equaling negative b over 2a, and that's going to give us the x value of the vertex. And then we're going to substitute it back in up here to find the y value of the vertex. So after we've done that, we're going to plot the vertex and find the y values of points with x values, one on either side of the vertex. Then we're going to repeat step 2, but we're going to go 2 away from the vertex on either side. And you'll see how that all works in a second. So here's our problem. And the first thing we're going to do is we're going to find the x value of the vertex by taking negative of b over 2 times a. And in this case, b is negative 14 and a is negative 7. So negative of negative 14 is 14. 2 times negative 7, negative 14. The result is negative 1. So I'm going to plug that back in to find the y value of the vertex. Negative 7 times negative 1 squared minus 14 times negative 1 plus 2. Negative 1 squared is 1 times negative 7 is negative 7. Negative 14 times negative 1 is positive 14 plus 2. So negative 7 and 14 is 7 plus 2 is 9. So I'm going to have an x and a y value. The x value in this case is negative 1 and the y value is 9. And that is my vertex. Now, I want to go one above that x value and one below that x value. One above would be 0, one below would be negative 2. Now, I'm going to need to do a little erasing so that I have room to do this work. So I'm going to erase this here. And I'm going to erase this, moving this stuff up. Ooh, helps if I put that down. Move all this up. And I'm just going to eliminate what's inside each of these, where the x's were, and I'm going to fill in my negative 2. Negative 2 squared is 4 times negative 7 is negative 28. Negative 14 times negative 2 is positive 28, plus 2 gives me 2. Now what's really kind of neat is when you put 0 in here, this expression becomes 0, this expression becomes 0. So when I plug 0 in, the ones with the variable are gone and I have positive 2. So whether, and I should have put that in red, let me fix that. All right. So when I go equal distant from the x value of the vertex, I get equivalent or equal y values, the same y values. Let's go one further. So we have 5 points, the vertex and 2 on either side. That's what I want minimum here. So positive 1 and negative 3. I'm going to put that negative 3 down a little further, so that they're separated a little bit more. And I'm going to go back up here and replace with 1 and then with negative 3. I can't see what I'm doing. That's better. All right. So when I put 1 in here, 1 squared is 1 times negative 7 is negative 7. Negative 14 times 1 is negative 14 plus 2. Well, that's going to be negative 21 plus 2 would be negative 19. And I darn well better get negative 19 when I plug negative 3 in. Let's see. Negative 3 squared is positive 9. 9 times negative 7 is negative 63. Negative 3 times negative 14. Well, we know that's going to be a positive. 42. Well, 42 plus 2 would be 44. If this was 64, that would differ by 20, but it's 63, so it only differs by 19, and the bigger number is negative, so negative 19. Sure enough, they came out the same, and that's what we want. Now let's do some plotting of points. Now, normally the graph isn't quite this long, so I extended it. Let's see, we've got negative 1, positive 9. Right there. The next number I have is 0, 2, or next coordinate. Negative 2, 2. See, they have the same y value. Then I've got 1, negative 19. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, almost the bottom. Negative 3, 1, 2, 3, negative 19. That is quite a steep graph. It's really hard to draw that accurately. So I try to draw the two sides separately to make sure I hit them. It's a sketch. We're not trying to be perfection. Your points darn well better be perfection, but the drawing of the sketching of the graph, that does not have to be precise. Do your best with it. Ones like that are much harder to draw than ones that are closer together points. Okay, so that's what a parabola looks like. This happens to be opening down. You'll notice a lot of similarities between graphing parabolas and what we did the other day, which is graphing absolute value functions. Very large number of similarities. So let's look at this one. The x value of the vertex here is going to be negative of b over 2 times a. Again, b is negative 4 in this case. A happens to be negative 1/2. Well, negative of negative 4 is 4. 2 times negative 1/2 is negative 1. So that's negative 4 for my x value of the vertex. Now, it might be smart for me to put my xy grid over here instead of down bottom, just to give myself a little more room to work. Negative 4. And now we have to find the y value. Negative 4 squared is positive 16. I'm going to take 1/2 of that in opposite sign. So negative 1/2 times positive 16 would be negative 8. Negative 4 times negative 4 is positive 16 plus 1. Well, that's positive 8 plus 1 is positive 9. Let's try a number above and below that. Negative 3, negative 5. I'm going to do some erasing up here so that I have room. All right, let's check it out. Y equals negative 1/2 times negative 3 squared minus 4 times negative 3 plus 1. Nine times negative 1/2, negative 9 over 2, plus 12 plus 1. Well, 13 minus 4.5. So let's see, if I took 4 away, that'd be 9. So another half would be 8.5. This one should also be 8.5. But it's not that difficult to graph half spots, but I would like to see results where it's at a crossroads here, at an exact coordinate, not partway along. So what I'm going to do is I'm going to go every other spot and see if that makes a difference, like -2 and -6, and see if that comes out at a nice intersection. So let's erase in here and see if we can get that. So let's fill it in with -2, 4, let's see, -1/2 times 4 is -2 plus 8 plus 1. So that's 9, and -2 makes -7. All right, that's much better. So if I put an odd value in there, it's going to give me fractions. So my next value that I want to plug in here is probably going to be 0 and -8. Of course, I'm going to do -6 first. So let's move those -2's. Let's eliminate that. And let's plug in -6 and see where it gets us. We've got the 1. We've got 24. And 6 squared is 36. Opposite sign cut in half. Half of 36 is 18. So -18. All right. So now I've got to combine that up. Let's see. This would be 25 minus 18 would be 7. Negative. Oh, no. Positive 7. Why is that one negative? Did I mess up? Let's check. And that's exactly what you need to do here. You need to check to see if you made a mistake, and I'm going to do that. I think I made a mistake in the previous problem. Let's take a look. -2. I might have made it. That'd be 4 cut in half, -2, positive 8 plus 1. Yes, I did. I wrote the wrong thing, I think. I think I just wrote the wrong value there. That should be positive 7, not -7. 9 minus 2, 7. I don't know why I put -7. What am I thinking? Here we go. Let's do another value. This time, well, if I put 0 in, 0 squared is 0 times anything is 0. 0 times anything is 0, so I'm just going to get a 1 there. All right, so let's do -8. Since we know, ooh, well, too late. Let's just do that. All right, so we're filling in -8. -8 squared, 64. Half of that is 32. -32 because of the negative. This is going to be positive 32 plus 1. Well, that's just going to be 1. These two cancel out. Now I can plot these points. Let's plot these points. -4, positive 9. -3, 8.5. -5, 8.5. Now, they can be helpful to have those fractional answers, or mixed number answers, but it's much easier with the integer answers. -2, 1, 2, 3, 4, 5, 6, 7, and -6, 7. 0, 1, and -8, 1. So you have to make sure you realize that we skipped -1 and -7. And let's draw our arcing graph here. All right, good enough. And there is the graph. Let's take a look at another example. X is going to be negative of b over 2 times a, and that's negative 10 over 2 times 2. So 10 over 4 is 5/2, or 2.5. That's not real nice, but it's what we're stuck with. We know that's 2.5. Now, if I go up and down, I can go up by 1/2 and down by 1/2, and that would make that 2.5 plus 1/2 is 3, and 2.5 minus 1/2 would be 2. And then I can go by ones after that.
At this time, students who are driving themselves home may leave. Attention all seniors, please do not forget to go pick up your food bags down near the gym. Thank you.
So now I've plugged these in, now that we've been lovely interrupted. So 2 times 25 over 4, remember you have to square the top and the bottom, minus 10 times 5/2 minus 3. All right, let's see. These are going to reduce to 25 over 2 minus, I'm going to leave that over 2 for now, just so that I can combine like terms. This would be a minus 50 over 2. I know that's 25. And then I'm going to make that into over 2, 6 over 2. Now it makes it a little easier for me to combine these up.
I apologize.
25
Actually, no food bags going home
minus
today.
50.
All of those students who are driving themselves, may
Give it
leave
1
at
second,
this
please, sorry.
moment.
25 minus 50 is negative 25, and another negative 6 would be negative 31 over 2. Well, 31 over 2 is 15.5, so negative 15 and 1/2. You can see why I had an extra little bit there on the graph. So if I actually plot that, that's 2.5, and then there's 10, 11, 12, 13, 14, 15.5. See how that's right in the middle of that square? Not a very nice place, but that's the answer for the vertex there. Now I'm going to erase all this so I have a little more room to work with, and then I'll plug in some nicer values. And you can do some of this work in your head, but it's always a good idea to have your work on paper so that it's a little bit easier for you to find mistakes if you've made a mistake. So, for example, 3 squared is 9 times 2 is 18. 3 times negative 10, negative 30 minus 3. So you could write that much down and do some of it in your head, and that way at least you have some of the information down. Now, 18 minus 30, negative 12 minus 3.
But seniors, you will be able to pick up your food planned down by the gym. Thank you.
All right. Total disruption. Here we go. Well, let me get back to what I was doing. 2 squared is 4 times 2 is 8. 2 times negative 10, negative 20 minus 3. It should come out to negative 15. This combined will be negative 12 minus 3 is negative 15. So I can come over here to negative 15, because that's negative 15.5, 3, negative 15. You can see the curve forming already. Let's go.
All students being picked up. may be released at this time through any front door. Thank you.
Yeah, we're going to get interrupted about every 2 minutes here. So let's see what we can do about getting past that. 4 squared is 16 times 2 is 32, minus 40 minus 3. That's negative 8 minus 3 is negative 11. And if I put 1 in there, squared is 1 times 2 is 2, minus 10 minus 3, same, negative 11. All right, let's plot those and draw this. Let's see, I did 1, negative 11, and 1, 2, 3, 4, negative 11. And it turns out if I put 5 and 0 in, they're both going to be at negative 3. So 0, 1, 2, 3 down, 5, 1, 2, 3, 4, 5, 1, 2, 3. And now I can draw my graph, and let's see. Yeah, I guess I'll just do this. I'm actually going to make that a little more transparent so we can see our points through it, maybe. That's kind of a neat tool. You can see the graph and see the points through it. I don't know how easy it is for you to see it on the graph, but here we go. Let's go to the next one.
Any student on boxes 1, 6, 11, 16, 21, or 26 may be dismissed at this time. Thank you.
All right, so in this one, when your equation is in the form y equals a times x minus p times x minus q, okay, not vertex form, intercept form is what I had probably intended to say was this section, then we're going to use p and q to help find the vertex. So the x coordinate of the vertex is going to be found by saying x equals p plus q over 2. Now the other day we talked a little bit about the h value being opposite what it looks like because of the minus. So p and q also are going to be opposite what they look like, and you'll see when I get to an example. You're going to plot the vertex, and the x-intercepts are going to be at p and q. In other words, where it crosses the x-axis at p and q. Remember, to find p and q, you need to only solve for y when for x when y equals 0. So in other words, you set each of these equal to 0 and solve for x. That's one way to find p and q.
Students on buses 2, 7, 12, 17, 22, and
ignore what I just said there. Let's just move on.
At this time. Thank you.
All right. So this is just throwing me off. So p here is going to be positive, not positive, negative 2. It's opposite what it looks like. Q is going to be positive 2. So x is going to be found by saying negative 2 plus 2 over 2. Well, that turns out to be 0 over 2, which is 0. So the x value of my vertex is 0. So I can make a table of values here, 0. So the y value, if I plug it in, 0 plus 2, 0 minus 2. 0 plus 2 is 2, 0 minus 2 is negative 2.
Any students
And that's going to be
3,
4.
8, 13, 18, 23, and 28 may be dismissed at this time.
I should have known better than to start the video at this time. All right, go up and down from there. 1, negative 1. I'm going to erase some of the stuff so we have room. All right. So 1 plus 2, 1 minus 2. 1 plus 2 is 3, and 1 minus 2 is negative 1, times a negative gives me 3. This one should be 3, but I'm going to check
As a
it.
reminder, any senior student picking up meal bags can do so down near the gymnasium. Also, students on buses 4, 9, 14, 19, 24, and 29 may be dismissed at this time. Thank you.
-1 plus 2 is 1. -1 minus 2 is -3. And when I multiply, I get +3. Sure enough, it worked. Let's do one more point. 2 and -2. Those will come out to the same values, but what value? 2 plus 2 is 4. 2 minus 2 is 0. So that's going to be 0. Let's try it the other way. -2 plus 2 is 0. -2 minus 2 is -4. Still comes out to 0. Let's plot some points. 0, 1, 2, 3, 4. 1, 3. -1, 3.
Lastly, any students on buses 5, 10, 15, 20, 25, or 30 may be dismissed at this time. Thank you so much, and I apologize for the confusion today. Thank you.
All right, so these 2 points are extra. I just was carried away with doing this. The vertex and the 2 X intercepts, P is here, Q is here. Those are all you really need, but it does help to have these others to draw in the result here. So the vertex is at 0, 4. Now, let me just change that color because that's not going to be a good color for what I was working with. Let's just make it blue. All right, so the other thing that I want to show you is it talks about an axis of symmetry. That means that's a line across which it does the same thing on either side. It's kind of like the human body in general has an axis of symmetry down its center. You have an eye on either side, an ear on either side, right? So the graph does the same thing on both sides of this vertical line through the vertex. And by the way, if I haven't mentioned it, this point is called the vertex. So that point, it's not very well aimed, that point is called the vertex. It's the point at which the graph changes direction. So if it's going this way, it's changing direction to go this way. That's that change of direction. Just like the absolute value graphs had that point of the V where it changed direction. Same idea. And the axis symmetry. I hope I spelled that right. I apologize for my spelling. I am an atrocious speller. But the axis of symmetry is the y-axis in this case. But if the point was somewhere over here for the vertex, if that were our vertex and it went like this, then this would be our axis of symmetry. Okay, let me put that back where it was and get rid of this so that we don't have that in the way. All right, let's take a look at another example. Now, before I even start, P is going to be 7, Q is going to be -2. I can actually plot those points right away. +1, 2, 3, 4, 5, 6, 7. There's the intercept. -1, 2. There's the intercept. Now, if you think about it, what we're doing when we're trying to find the x value of the vertex by adding 7 and -2 divided by 2, that's the average, isn't it? So that's the point halfway between them. So if you actually went 1 in, 1 more in, 1, 1, halfway between right there, that's going to be your vertex, x value anyway. So this is 5 over 2 or 2 1/2. 1, 2 1/2. Sure enough. All right. So the y value, I'm going to write it as 2.5 just because it makes it a little easier to do this problem, at least at first. 2.5 minus 7. Well, if I said 2 minus 7, that would be -5. So if I take another half away from that, that's -4.5. Let's see. -4.5. Isn't that -9/2? Let's rewrite that. And 4.5, that's going to be +9/2. And look at this. Oh my goodness. The 4 is going to reduce with both of these. And that just leaves me with -81. Wow. My vertex is going to be tremendously low. In fact, I'm going to have to scale it. This would have to be, for every number here, to get 81, I'm going to have to go by 5s. 20, 30, like that. And the rest of it, I'm going to have to go by 1s. So 0. Let's start again. 1, 2, 3, 4, like that. All right. So to plot that point, 2.5, that's not quite at 2.5. It really needs to go over a tiny bit, right? Right there. All right. Come on, behave. 2.5, and then every 2 squares would be 10. So -10, 20, 30, 40, 50, 60, 70, 80, and just a tad bit more. Wow, that's not easy to graph. And I'm not going to bother to get any more points, but I can do this, and that's a good enough sketch for what we're doing. Okay. That's your homework, but that's going to be in Google Classroom, so that's it for today.